All right. And like we were just talking about a second ago, section 17, doing APIs, application programming interfaces. No one calls it that. It's always APIs. And basically, it's a way for you to communicate with basically another, I mean, usually in this context, we're going to talk about like a client and a server model. But note that APIs can also be like internal. Sometimes we'll talk about like the TensorFlow API. It's like you're talking about using a module or a library and talking to it back and forth. But usually when we're talking about APIs, at least in the data science context, we're usually talking about talking to a server and getting information from that server.
Right.
So, yeah. Yeah, and like Josh, like you said, or like we were talking about, if you have a computer science background, this might be kind of more review, or like you interacted with this a little more. It's kind of the classic way of interacting with really a server. So let me go ahead and start sharing my screen. And Zoom just likes to cut off my windows when I'm trying to share. Okay, so you should see APIs, application programming interfaces at the top. Is that right, Josh?
Yep, I can see everything.
Perfect. Okay, cool. Let me bring you back so I can see you. Okay, so this is kind of like, I like to think of it like the tiers of like what kind of like data you can get. And so like not the simplest, but like one of the like quote unquote best ways you have it is that the data is immediately accessible to you. And that could be like in the cloud, that could be on your server, or not your server, on your own system in some way, is that you don't have to wait for something else to get it for you. Okay, that's kind of like in my mind, like the gold standard. Be like, oh, cool, we have all the information on there. Now, in reality, there's a lot of reasons why that doesn't come to fruition. One is like, if it's a very large data set, it won't fit on your local computer. If it's in a cloud setting, there's ways to get the information out of it. So you can think of it like when we talk to, when we do SQL, for example, we're doing a SQL server, we're asking for information from a server, from some other basically computer, and it gathers information for us. APIs are kind of similar to that. APIs, I would say, are pretty high up on there where there's something else that organizes the information and you can interact with it programmatically to give you information and kind of aggregates it together. Now, some of that data might not be necessarily tabular formula. Usually it's sent in JSON, sometimes XML. JSON tends to be the more modern way of passing information, like we talked about, I think it was the last time we talked about JSON and XML and recursion. But JSON usually is what the information you get back there. You get this information and you can parse through it. And there's basically, you can use APIs for a lot of different ways. In data science, you were talking about getting data, but also could just be to control things too. And we'll talk about that. So the way I like to think of APIs is the way of communication. So when we do a communication like with API, it's basically an application to another application. So that's kind of like the best way to generally think about it, is that it doesn't necessarily have to be a server and a client, which we'll talk about mostly, but it's sending information from one application, essentially one program, to another program. And so you send a request essentially. So let's say you're on your side, you send an API, use the API to send a request. And usually you give it some info. Sometimes you're asking for a specific thing. Sometimes the API will just say, hey, if you just ask at this specific like URL, it'll get a response back. And that response usually is some data, something about this, maybe some metadata about the data or about the service itself. You can think of like your browser in a way, kind of like doing an API request, and in a kind of a loose kind of way where when you go to a URL, you really are asking the URL, say, hey, give me the information for this website, and it passes it off to you. And if you go to the wrong website, it gives you like a 404 error. So that's kind of like a similar idea of like where you're asking information from something else. So I put a few examples on here. So classic ones like financial transactions. So like if you are developing a program or a program's developed and you want to send it off to some, let's say Venmo or even like a bank or something, you have usually some kind of system to send information saying, hey, this payment needs to be made to these accounts. And basically it processes that information and sends you back, saying, hey, okay, this information has been processed, maybe there's some information. It's like, oh, that routing number was incorrect, like an invalid routing number or invalid, credit card number, something along those lines if it was something that had to be on the server side. So these are kind of things that you typically would see. Twitter has like a really robust API that's been really famous. You can make like bots and stuff like that. And there's a whole bunch of things you can kind of do, like really interesting things and also kind of nefarious things depending on, exactly how you approach it. But the point is that you can basically use an application to post and interact with Twitter back and forth. And then one thing I'm going to talk about is controlling IoT, which is kind of a big space right now where people, and usually more enterprise space, but there's also like home IoT stuff where essentially asking things like, an IoT stands for Internet of Things, in case you weren't familiar, but basically you can get information, you can ask for like temperature sensor data. If you have a temperature sensor, you can ask it to do certain things. For example, if you have lights or, other connected devices, you can say, oh, go ahead and do these things. And it's all usually interacted with an API, okay? So really you can think of it as like a software to software interaction. So we basically give information from one application to the next application, and it processes that in software somehow, okay? Cool. So that leads us to like just the parts of the API, and these are more like definitions. This comes from the curriculum as well. One thing we would talk about is basically it needs to know who can access it. So this depends on the API. Some APIs allow you to anyone access it. In fact, sometimes it even allows you to not even authenticate of who it is. That tends to not be so common. The reason why is because if you can't authenticate who it is, you can basically bog down the system either on purpose or by accident. And so usually we have like access permission saying, who can access these points. And usually I have to get something like an access token to basically authenticate or basically get permission. Well, not just a permission, but also just to say who you are. Okay. So the main part though that we'll kind of think about mostly is your call and request. So like your call, like I said, like you're asking for information. So you can think of it like using code to make this call, let's say implement a complicated task and features. So instead of you doing the whole thing on your end, you can say, hey, I want this stuff. And essentially some other computing system, some other software will do this for you. That's the kind of the idea of the API. You're offloading that information off of you. And instead you basically say, you go ahead and do this for me, okay? And then just know it's kind of like, let's hear methods, what questions can we ask, parameters, more info to be sent. So basically these are just different things we can do. So methods you can think of as like, oh, do this specific thing. And then you might ask for parameters, say, and this is some information you can do with it. So for example, you can say something like to Twitter API, say post this post with this information on it for this tweet on it, or with this picture attached to that tweet. So those are things that you can do with the API. And then a response, usually if you're doing, every API should have some kind of response, and it usually at the very least will say success or failure. Sometimes it can tell you specifically what kind of failure it was. It also can be a response of saying, instead of saying, hey, Twitter, post this for me, you can say, hey, Twitter, tell me all the past tweets with this hashtag in the past hour or in the past day or whatnot. And that will send a result backwards and say, oh, success, and we'll give you this information backwards. So this is the kind of idea where, as a data scientist, we can request information back and forth from systems, okay? So this leads us into different types. Main ones we're going to think about are like web and databases. So the web interfaces, you can think of it as a server and client, which we'll talk about in a second. And there's like the Twitter API, like I mentioned, which is pretty robust. And this is all just the documentation directly on here. So you can see, you can learn about, for example, the way you can use this API. And depending on like really what it comes down to, it depends on the company itself, how they document it. And some people say like, oh, how do I know what thing to use for the API? You don't know until basically someone tells you, or essentially you might accidentally come across it, but usually you want to go for the documentation because it can be very complicated. And so another one is Amazon S3, and REST stands for, well, we're not gonna talk about REST right now, but basically, sorry, I lost my train of thought because REST does stand for, and it's blanking on my mind. Oh my gosh, I can't.
I was gonna Google it. It's representational transfer. Or
let's do this real quick. There we go. Nope. Let's go RESTful API. I'm so sorry. I feel so bad. It's popped out of my head.
Yeah, no worries. I forgot too. I was just like, oh yeah. It's like you don't really call it that either. Like APIs and REST, you don't really say representational state transfer. It's just REST.
Yeah. Okay.
REST services, REST API.
Okay, it's weird. I don't know why, like it just popped out of my head, but okay. Yes, but REST is, you'll see that again and again in APIs. And there's a reason why, is because we want to make sure that the way we interact with it is proper, or it has certain properties when we interact with it. But anyway, S3, this is usually a lot of data storage, basically. You'll see this really commonly in a lot of data science, like just keeping the data in there. For example, using Kaggle, usually there's some reference to an S3 bucket or something like that where you can store a lot of information. So again, all of these have different documentations and how to reference everything that we need. Okay, all right, and then just know that the curriculum talks about operating systems and hardware. These are other two ways that you can interact with the API. So operating systems, you might have an API. Again, I'm not going to talk too much about it. Basically, it's like software to software interaction. You also have APIs with hardware. So like your computer, basically it's like, how does your computer know when I press the letter A on my keyboard? How does it know what that actually is supposed to interpret? It's basically through an API, it's to interpret at some level. But I'm not going to worry about this too much. Curriculum has a lot more information. Okay, so let's go to our client model, server model. So this is kind of basic. This hopefully will feel pretty familiar to like SQL servers and stuff like this. But the idea here is that we have like a distributed architecture. So we have some way of like having the servers. The servers really are going to be doing the meat of the work. It's going to do all that stuff. And usually we say it's physically separate. Technically, a server can be on your own system. You can actually emulate a server and emulate an API. And an API can be basically, like we talked about, the computer. It can be the software built onto your computer. But usually when we talk about getting information, like data from an API, usually we're talking about something like an outside server, and we're going to query information basically from that server, and they're going to do all the work for us. And our client is basically us. We're the one requesting the information. And again, kind of relating back to the different types, it could be hardware or software. So in this case of having like the letter A pressed, that would be a hardware, basically API interaction, versus software where we might programmatically actually ask like, hey, give me this information, or here, do this for me. Okay. So client, don't even really define that again. I'll just leave that there. Server, same kind of deal. I think at this point we kind of have an idea of like what a server is, what a client should be. But the main thing is that your client is the thing that's requesting information or requesting some method, basically, and the server is the one that's receiving that information and will be giving out a response. So the server actually has a lot of things that it has to kind of think about. So I talked about authenticating. There's a whole thing that we could talk about with computer science with how authentication works and what are the needs for authentication, because that's not quite the same thing as authorization. And authorization basically says if you are allowed to look at this stuff. Authenticating just says, are you the person that you say you are? And those are related, but not necessarily the same thing. Sometimes they are. Like usually we can talk about your username and password as authenticating that you are your person, or you're that person, but also you have authorization to access this profile. But they could be separate. And that's kind of like what you'll see in the APIs a lot of time. Will authenticate us by having a token that says, hey, this is me and this is my application. And then on the other end might say, okay, these are the authorizations you have. And so just know the server looks for this kind of stuff, and then looks at the request that's being sent out, and then performs actions after it authenticates or authorizes, and then it sends a response. Okay? Whether that's just to say, hey, everything looks good, I did what you're supposed to, success, or it says, oh, there was an error, or it might say, hey, here's a bunch of information, some extra data, usually in a JSON format, maybe XML. Okay, and then database, we know what a database is. It's just basically something where it stores this information. Like, we don't have to go over this really. Okay. So one kind of famous one, not famous one, but one that's really common is HTTP requests. So these things can be really useful when we do web scraping. So we can actually say, hey, go ahead and request basically this web page, and we can actually get the web page, which is we'll talk about, I think, next time for HTML and CSS. Basically say, oh, show me your web page, and we can go ahead and take that information and scrape through it essentially and get extra stuff. So in that case, the server basically isn't giving us, isn't pre-processing a lot of the information. the server might just basically giving, all right, here's the whole information, like here's just the whole web page, and we have to go through it too. So note that just because we're using an API of some in some way related to HTTP requests, we might still have to do some pre-processing. But hopefully, if we have a good API, it will give us consistent information and we know how it's going to be structured. But this was something that was brought up in the curriculum, HTTP requests, just because we do it so often. And so I think there's a little code example. Oh, good. So there's a really popular library that we'll use again and again, which is request. Okay. And so request basically just allows us to get web page data, which is actually really great in the sense that we can use this to, what's it called? Web scrape. We can get it, we can look at the web and scrape across and get the things that we need for our data. Okay. So for example, here we have a response. Basically, we're just going to go to google.com. This is all inside the curriculum, but it's just basically kind of showing a little bit. So when it does this request, it's like your browser going to www.google.com, and then we can actually have certain things like in an object form. It has a status code, and we can also see the different codes that are built into requests. For example, an OK, meaning that is status OK, or is it disconnected? And we can see here response code was 200, which means it's actually okay. It's up and running, thankfully. Google still exists. Okay. So other things we can do, I think this will not be super impressive because it's Google. There's not too much to Google. But you can see this response.txt. And basically, if you look at this whole thing right here, we haven't talked about HTML, but when we go into HTML next lesson, we'll see that basically this is written in HTML with some CSS, and this is essentially the page itself. And there's some extra stuff right here. In this case, it tends to be, I think these are other attributes. Oh, these are like Google. These are JavaScript functions and stuff like this. But the idea here is that this is literally the Google web page essentially. And so normally we don't, what's it called? We don't usually look at the code. We don't look at the HTML directly like this. Our browser takes that information, interprets it for us. But we can see something, for example, let's say, trying to think of a good example that we'd want to scrape. But if, let's say Facebook, let's say we're someone to get into Facebook, we have to log in, go to there, and you want to pull off all the people who are like your different statuses that are pop up on Facebook, right? And in that case, I realize I haven't been on Facebook for a long time, so I'm trying to remember exactly what it looks like. But you can pull off different statuses for each part in there, and you could do that by basically looking at the HTML page and looking for certain what they call tags, essentially similar to how XML is formatted, and look for those parts and pull that information out. That's kind of what web scraping is. So that's what this allows you to do. Okay, response.txt. But in this case, let's see here, I can get specific parts, for example, the headers, which is basically like the metadata from the request. So for example, you can see when I requested it, some other information, seeing if there's anything like anything that's like damning for me, like IP address, but I think we're okay. But you can see, for example, the domain is google.com. It's basically just extra information, okay? And then you can see, for example, I can get this because it's a dictionary. We can get the specific date or server. So it turns out the server is called GWS, which makes sense, probably Google server, okay? One thing you can do is you can pass in parameters. So you can do the same exact thing like we kind of did up here. Basically just ask for Google, but we can also say, all right, let's pass in some parameters before we actually pass in the URL. And so for example, this might be a classic, like, okay, you're gonna put in credentials, what's your username, your password, and then you'll actually have the website, and maybe you'll actually pass in a parameter within it. Basically like, in this case, a username and password. Note that this http bin.org is a great way to practice like just different requests and stuff like that. It's basically a dummy site, but kind of gives you the, kind of helps you see what the kind of things would happen if you pass information and what kind of results you might have. And you can see here, basically just printing out some results. So most of this stuff will basically just be, what's it called? Yeah, you see, I got rid of my IP address because I don't want that to, and we'll just put that out there. But the point is that you can pass information. In this case, we're just passing text, but we can also put in, for example, we can pass in actual images, so binary files and stuff like this. And you can see here is that we actually can post this into here. I didn't print out the text because we don't need to worry about that, but know that we can pass in information that way too. Okay. Any questions so far you may have, Josh?
I'm good with everything so far.
Okay, sounds good.
It's like it's starting to come back to me now because I haven't really like read or have done anything within the while, so it's kind of nice to
A
see
little
it.
refresher, yeah. Yeah. Cool. Awesome. Yeah, and I feel like, a lot of this just ends up being just like getting used to doing this specific thing, but the concept's hopefully not too bad. How to how it works at least. Okay. So last part before I show an example is OAuth, so open authorization. So this is kind of going the same thing where authorization versus authentication. So authentication is much more of saying like who you are. Um, OAuth though is kind of like saying if you are allowed to have certain permissions. So I'm not going to go too much into detail about this stuff. The curriculum does kind of talk about this for some time, but this is a bigger deal, especially if you're on the server side of saying, who do you allow to access your information? This tends to be much more on the software engineering, a developer side, where you're trying to, if you want people to access information, which might come up depending on what kind of job you might have. That might be something that as a data scientist, you might collect a bunch of information or have data that's already in your company, process it, do something with it, give some information, and then you might say, okay, allow other people to maybe send requests. So for example, let's say you make some machine learning algorithm or machine learning product where you've trained a bunch of, let's say you take a picture and you're able to see is it a hot dog or not a hot dog. And you can basically take a picture of that and you can have users now. So you have this new model that's basically can say, oh, is this picture a hot dog or not? And it's like, oh, awesome. So now you can maybe deploy this and have other users basically outside of your company use the API to say, all right, here's a photo. Tell me, is it a hot dog or not? And you can send out information, say, oh, no, it's not a hot dog, or yes, it is a hot dog. And these are things that you would have to worry about actually creating. Again, I'm not going to really spend a lot of time on this, but just know that basically OAuth is kind of like, what's it called? It's a pretty common way of authenticating and authorizing. So one thing I kind of mentioned here is avoid abuse by limiting. So one thing that you can do if an API is not correctly written out is if you basically allow anyone to essentially just keep asking for information, that can basically bog down your own server or whatever server you're asking for. So to avoid that, basically you might do authentication to say who is this, authentication to say who is this? Like, oh, it's this one person. Well, this one person asked a request, 5,000 times within the past like half second. It's like, well, that's a little too many. We're gonna go ahead and limit that user for now, or maybe they'll, sometimes they'll completely ban it, but usually it's like, oh, we'll give a cooldown time. So you're only allowed to go 30 times every second or something like that. So this way it allows you to, first of all, prevent people who are purposely trying to like mess with the system. It also can happen where someone might have written a program where they didn't think it was going to call that many times, and you want to make sure that they don't keep calling it by accident, essentially. So yeah, so that's pretty much all of APIs. Very quick broad strokes. Main thing about APIs is just that as a client, you are sending information, some packet load, some info, and you're saying, hey, server, give me some information based on what I'm giving you. And then the server basically decides, if it's written in the way it's written, says, okay, let me look at your request. Okay, your request looks good. You say who you are. All right, awesome. Let me go package some information to you and send it back to you, the client. And then you could, as the client, get new information and you can decide what to do with it from there. Cool. All right, any questions? Yeah, Josh?
Nope, I'm good.
Okay, cool. So this leads us into an API example, which I think is just kind of fun. So one thing I mentioned is IoT. So one thing I like to do is I actually have try to build some parts in my smart house. And so one thing I have is an API right here, or I use smart lights, which is actually right in this little corner right there, standing over there. And so what's kind of cool about this is that we can use the API to interact with it. So I'm going to kind of walk you through this part. And I'll show you this documentation here. And so, for example, this is LifeX, which is what I use for one of my smart lights. And just know, like, basically there are different they can show you here the API documentation, what kind of response you have, what kind of things you can do. So for example, I can list the lights. I can also do things like toggle the power on and off. I can also, in this case, change the light color, saying like what kind of colors they have. And they kind of like all these different things you can kind of mess around with. And you can see here, in this case, it even shows you in Python what to do with. But really the important part is saying, what is this URL that I can ask for, and what kind of, what's it called? What kind of data can I send it, and what kind of information do I get back? So I'll kind of show you what that looks like. So this right here, you'll notice that I have this secrets import lifex. And so this is a file that I created. So secrets.py, but I'm not going to show it. Not that it's really dangerous or anything like that. I just don't want to show the API key or the token in case there was something that is not supposed to be in there. But the main idea is that I created this class right here, and it's called secrets. This is just a copy, so it's not real stuff. And it's to help organize things. So this way you can make sure you can keep like a specific API token. So you can generate, you basically go to lifex and you say, hey, you just log in and say, generate me a new API token that says it's you. It's a free API. It doesn't cost you anything. It just wants to make sure it's authenticate that you are, they can tell who you are. And so they give you this token, and then basically you can take that token, put it in here. It's just a bunch of random letters and like a really long thing basically, and to authenticate that it's actually you. And I'm just storing in a certain way. So that way I can access it a lot easier. So let's go back here. So just know that's what I'm doing with that secrets. And this also allows you, when on GitHub, if you're uploading stuff to GitHub, you can keep your token that's supposed to be basically uniquely you. You can keep that separate from the code you're actually running. So this way, if I upload this, like I did already with GitHub, you would be able to access this, but there is no file called secrets. You'd have to create your own secrets thing. So that way my token's not here. Because in a second, I'm going to let you be able to you can control my light if you want from like wherever you are. So yeah, I'm sure you'll like that. So just kind of show you what this basically looks like. I got the request. I have JSON in this case, so I can kind of process some stuff. And you can see here, basically this comes, I think this actually comes from similar to here. In this case, I'm just going to list my lights. So just looking at this part, you can see here, it's basically, I have my app token, and this is just some information, just a header. This is not necessarily. And then right here is my request. So you can see here, I go to a specific URL, list all lights, and I can say a specific header, which is my token itself. So that's what I'm doing right here. You can see here, I have my token that I have in here that you can't see, but it's in there. And I can send the header and the response. So right now I have a response. You can see it ended. So I can actually, all right, let's check what the lights are. Basically that's response.json, it's a JSON format, and display that. And you can see now as that I get a JSON format, in this case it's a list. And you can see carefully, basically it's a dictionary, and this basically has an ID, a label. For example, I have a front light here. You can see the power is on right now, so it's currently on. You can see the color, so this basically allows you some information about the color. There's colored lights and stuff like this. In this case, this one has an effect. Also, there's some groups. For example, this is my front yard. You can see my location, it's my home, and all that stuff. And then they even have, which I love about APIs, sometimes only LifeX makes this, but they made sure that they have the company LifeX, so in case it does expand to other things in the future, you'd be able to get information about it. And you can see last seen and all these information. And you can see now I have the second light, for example, my bedroom light. So anyway, there's 4 lights in this case. If I wanted to import as a pandas, right, to kind of check it out, you can see here I have 4 different lights. You can see their different brightnesses are all set. You can see if they're connected or not. Okay, in this case, we have one that's connected, this light right here. In this case, it's my living room lamp light, which actually turns out to be right here. I just moved it over so we can check it out. Okay, and some extra information. And note that sometimes if there's a nested dictionary within it or a nested JSON object, this won't be properly put in the pandas. We've seen this before, I think last time. So you can see here, we can see what all the lights are. You can see, oh, my front light, bedroom light 2, living room light, and bedroom light 1. Okay, and so I can send a payload. So for example, here, this is, I believe I want to set the state, and I can set the state with this information. So I can basically say a payload and say specific things that I want. So in this case, I'm just going to say, all right, go ahead and select this specific light with this ID. So I'm just using the light that I got already from the request, and say power on. And so if I set this, this should turn on my light. So it turns on. So you can kind of like basically do a control directly from this API. I can also change the color. So let's say I change it to blue. I can do something similar, and now I can actually change the light to blue over just through my program. And you can see here, it also gives me a response. So you can see response.content, and it gives me information that says status okay, basically that this is successful in what I did. Cool. And then of course I can turn it off. So there he goes. Okay. So I actually have it in here just to kind of prove that I'm not having someone just randomly turn on and off the light with my thing. I'm going to send you, Josh, my Colab notebook. So you should be able to access this. And what you should see is this guy here. Okay. And if you run these now, and I kind of hid the secret, that way no one can see it. But you can go ahead and, like, if you want to try it out, try running it, going from the top, in this case, the request right here. There's some secrets basically that allow me to do the credential. Honestly, it's not that big of a deal. I wouldn't really care if someone did end up doing this, but I'm going to disable the token like after this class. So you can't continuously change my lights forever. But if you run this.
That's the thing about that's the reinforcement with the token. If somebody has it, then it lights is kind of innocent, but anything else, it gets really.
Yeah, and I can revoke the token too. I've already done this before. I revoke the token, that way used again. I'm just being extra careful, especially since it's being recorded. I just don't want it to somehow, if there's something like, oh, they didn't generate the tokens properly, now you can generate any token you want. There you go. So you turned it to blue.
Oh yeah, I saw. I was like, oh, okay, there we go.
Yeah, and you can go ahead and change. Yeah, so you can change it to different colors. You can also, I think in this documentation, I see you in it now. So, so you can see you can control a bunch of these this thing. And what's kind of cool is that this is all done through through the internet, in the sense that now anyone can basically control it. Say, oh, it tells basically what you're doing. You're the client. You're sending a request over to LifeX's servers with that URL, with the api.lifex.com. And then it sends an information down, says, oh, hey, they're doing some stuff. Let's go ahead and send it down to Victor's light over here, over in California.
Right.
So you can all do all this, kind of stuff. One thing that's kind of cool too is that I didn't really show this part, but you can actually use the API in this case locally. So you can actually use, basically send out a broadcast without ever connecting to the internet. Through your own basically router, and so you can still use the signal that's in the house, but never have to go to the LifeX server. So in that way, you're sending it directly to the client and the server. The server really, in a sense, is you use the API to send it to yourself, and then your computer can basically send out a broadcast and act as a server and sends out a different kind of signal that tells that light to turn on and off offline, essentially.
So that's something you have to stand up manually. I've had Raspberry Pi, and you can basically do the same things with the Pi as with the regular server, just smaller scale things.
Yeah, so in that case, it ends up being UDP broadcast, and so you can basically just have a huge broadcast onto your Wi-Fi network itself. I actually use Raspberry Pis to help control a lot of this information. So actually I might have one right here. Do I? Not a Raspberry Pi, but I have different, I don't think I have it right here. I thought I did, but I have some sensors that's connected to my Raspberry Pi that do temperature and stuff like that. And that allows me to basically create my own little network and stuff. And that basically connected through essentially I make my own server that has their own APIs. So it's an internal part, so no one else on the internet can connect to it except for me if I authenticate it. And then I can decide how to interact with it and stuff like that. So yeah, anyway, that's I thought this was kind of a fun way, because we could have talked about using Twitter and getting data and stuff like this, but this makes it a little more fun because you get to see you get to turn on my lights and stuff like that. So.
Yeah, I'm sure we'll probably touch Twitter's API and use it for different things anyway. A lot of people use it scrape for sentiment analysis and other things. Or just
absolutely.
Something that they need to find, a hashtag or something.
Yeah, and for example, the way I think of it is that APIs are kind of the golden standard. Oh, if I have an API, awesome. And then the next part underneath that's like web scraping. It's like, all right, I can web scrape kind of thing. And then after that, I mean, I guess, no, I would say, I don't know. I would say like API, your own file, so like a CSV file, like those are kind of like mixed depending on the situation. And then like kind of the worst thing is like web scraping, where it's like completely raw data and you're just like, oh, I have to just basically scrub through this and figure out what the patterns are. I think I mentioned this before, is that I was doing web scraping on basically the Olympics, and I built the whole thing, and like, over like a couple months, I think, because on and off, it was just like a side project for fun. I was like, okay, cool. Like, finally got the whole information through there. There's a couple things I wanted to do. It's like, okay, before I run the whole program to basically go through the website and scrape it, like I'll do that tomorrow. And I'm not even joking. I literally was like, all right, I'm going to do this tomorrow. And the next day they changed the website format. So all my web scraping was completely worthless because it didn't work anymore. So those are the kind of things you run into when you're web scraping.
Yeah, it's broken. Or some sites just don't like to be scraped at all, and then it'll
Yes.
it'll determine that you're like using a bot to go through and do it. So.
Yes, there's even other ways you can do it. Like I think Airbnb does this, where they encrypt their so the HTML you can see HTML because otherwise the browser won't be able to read it. But the tags within the HTML that say what these things are, whether it's like an image or something like that, usually websites will keep it consistent. But Airbnb does something interesting where they basically encrypt the tags. So you can't actually tell just by web scraping what those tags are. And so what ends up happening is that the reason why they do this is so that way other people can't scrape their website and get all the information that's on their Airbnb. And I think LinkedIn does something similar to this too, where basically you can't read the class tags and stuff. So there's certain websites that they do certain things to make sure you can't web scrape and things. Like technically you can do it, but it ends up being a less automated process, which beats the whole purpose of why a lot of people would want to waste web scrape. They basically get a lot of information from it. So yeah, cool. All right, well, I'll go ahead and stop recording unless you have any questions, Josh.
Nothing for me.
Okay, cool. Yeah. And I'll make sure to revoke that token in time.